Good morning, Grayland. I wanted to record a short video kind of in place of me lecturing about how to input data and analyze it. Um, what I want you to do to start off is I want you to take a look at this question that Emma has. Emma is growing pumpkins at her house. She has some pumpkins in her shady backyard and some in the sunny front yard. So she's got pumpkins planted in both spots. She puts 1 cup of fertilizer on the ground surrounding each plant. She's curious to see if the number of cups of water she gives each plant daily affects the final weight of the pumpkins. Some pumpkins are orange, some are white, and some are green. Some pumpkins are round, some are oval. So I actually want you to pause the video right now and then answer these following questions here on the sheet that I have given you. And if you're not here at school today, you can grab that off of Haiku. Okay, so you should have now unpaused that. The hypothesis. It's probably easiest to actually answer the hypothesis after you've identified your variable, so that's what I'm going to do first. The independent variable is the thing that she's changing. You could actually get confused here because she has 2 independent variables, one that she is actually a controlled variable that she didn't control very well, and the other one is the independent variable she chose. The fact that she planted some in the shady backyard and some in the sunny front yard, that would be a control variable that wasn't well controlled. That doesn't mean it is the independent variable. The independent variable is the thing that she's actively changing purposefully. So what that is the number of cups of water she gives each plant. So independent variable would be amount of water, and dependent variable is what she is measuring. Now you might be tempted to put down something like whether they're orange or they're white or they're green or round and oval. Those could have been dependent variables if you wanted to measure and see if the amount of water affects its color or its shape, but that's not what she's curious about. She's only curious about the weight. So the dV is going to be, I'm going to say final weight, and control variables. I wouldn't put any of these things down. These are dependent variables, or possible dependent variables that weren't chosen. I'd put things down like amount of sunlight, amount of fertilizer, maybe the brand of the pumpkin. Those are or species or whatever you want to call it. Those are all good possible CVs there. So our hypothesis should follow that format of if, then, because, and remember it's if independent variable, then dependent variable because of our theory. So our independent variable here is if the amount of water. Well, or we have to go with the direction with this. So if the amount of water is increased, and I'm going to specify a bit. If the amount of water given to pumpkin plants is increased, then the dependent variable, the final weight, then the pumpkin final weight will increase. So notice that I've got increase and increase on both of these. I'm not just saying change because of your theory, and that theory could be anything that for photosynthesis to occur, the plant needs water. Okay. So you could have thrown a lot of different possible theories out there. So that is what we are starting with here. And then we're going to go to our data table here. So I'm using Google Sheets. That's what you should probably use. If you want to use Excel, that's fine. The nice thing about Google Sheets is you can share your data with your classmates very easily. So the first thing has to do with the data columns here. Which one do I want to put in the first column? Which one do I want to put in the second column? Well, it actually really matters. You always want to put the IV in the first column and the DV in the second column, and you don't need to put the CV here. So I'll explain that later. The independent variable, as we said on here, was the amount of water. So I will say amount of water, and then in parentheses, cups. So hopefully this is review from the video you watched over the weekend. Dependent variable was the weight of the pumpkin, and I need to give this a unit up here, so we'll put it in pounds. How about? So amount of water in cups, weight of pumpkin in pounds. I'm just going to make up some number. Let's say you didn't give it any water. We'll do so Emma did multiple pumpkins for each kind of amount of water. 1 cup of water, 1 cup, 2 cups, 2 cups, 3 cups, 3 cups, 4, 4, and 5, 5. So making up my weights of the pumpkins, let's say 30.7, 29.5, 31.1. This is just me, like I said, making up numbers. These are some big pumpkins. Obviously, I'm kind of going with an overall trend that I want you to hopefully see from this. So once again, you should see this over the weekend that you don't need to label these individual numbers. You just need to put them in as numbers, but you need to label the column, the headers for those columns, and you can organize it a bit. I like to put things centered, make sure that those are kind of expanded out there. If you want, you can add a little border on maybe on the bottom like that to make it look nice. You can always change your font, kind of whatever. I like to go with Garamond. It's my font that I like. Oh geez. Okay. So now comes the kind of new part. So we already mentioned that you need the IV and the DV. I had some people asking me about things like in their reaction rate experiment, they were saying, hey, do we need to include how much water we used each time? Well, if that was a CV, you don't need to include the CV in your data table. So for example, the fertilizer, I would not need to do this where I had fertilizer 1 spoonful and then said 1, 1, 1, 1, 1 all the way through there like that. That's not a step that you need to do. You only need to put your independent and dependent variable in your graph. Okay, next, we're going to actually go ahead and graph this. So you can select all of that data, including the header titles that will save you a little bit of time later. And now you actually want to go ahead and graph this. To graph this, you need to not go up here. In Excel, it actually is up on one of the top things up here. In Google Sheets, there's a little picture over here that says Insert Chart. So you go to Insert Chart, and the type of chart we are going to be using always is an XY scatter. So notice that they have some recommendations. You could select it right here from the recommendations, or you can go to chart types and scroll down to scatter. We're not going to really be using many bar charts in this class. Almost always we will be using scatter plots. Okay, so what I want you to notice here is that we've got an x-axis, we've got a y-axis, and they have defaulted to putting the first column on the x-axis, the second column on the y-axis. That's how it always works. We always want to put the independent variable on the x-axis. We always want to put the dependent variable on the y-axis. Sometimes, whenever you use Google Sheets, it will default to doing that. First column is X, second column is Y. So that's why the order actually matters of how you put that in there. And you notice because I selected my headers, it put those labels in there already. That's something you definitely want to make sure goes in there. Unless you're graphing different types of data on the same graph, you don't need to have this legend over here. So I'm going to actually get rid of that if I can. Just like that and say none. You don't need a legend if there's only one type of data on there. And what I need to do now is I need to rename the title. So there's a format that I want you using for all of your graph titles, and that is the effect of IV on DV. And you can be a little more detailed than that. You'll see what I mean. The effect of IV, that's the amount of water. So I'm going to say the effect of the amount of water, or you can actually be a little more general here. You could say the effect of changing water on the dependent variable, the weight of the pumpkin. So on the final weight of pumpkins. And I probably should either capitalize everything or nothing. So I'm going to capitalize everything on the final weight of pumpkins. Okay, so that looks nice now. Probably want to center that if you can figure it out. Come on. There we go. Okay, so I'm failing here on figuring out how to center it because it keeps on putting that pop-up there. Let's do this. Okay, that's weird. So I'm struggling to center that title. It would be nice if that title was centered rather than having pumpkins right over here. That's just more of a stylistic thing, though. So once again, the effect of Ivy on DV. The reason for that is you want your graphs to be, somebody wants to take a quick look at your paper, your report, your lab report, whatever. You want to know exactly what you're looking at on that graph. You wouldn't want to title this pumpkins or water and pumpkins. You want to say what you're doing with the water and what you're doing with the pumpkins. So that is kind of how I want you setting up these graphs. A few other things to note, things that could either make your graphs look really amazing when they're not, or really bad when they are amazing. It has to do with the axes. So notice this axis actually starts at 25 right now. That makes it look like there's a pretty decent sized impact on the final weight of pumpkins. If I click on this, I could make the minimum 0 and make the maximum 100, so 0 pounds to 100 pounds. All of a sudden it looks like there isn't really much of a difference if you're just taking a look at this. Let me make it really drastic. Let's make it all the way up to 500 pounds. It doesn't look like there's any difference at all between as you're adding the amount of water and you're changing the number of pounds. It looks like it just doesn't really make much of a difference. And that doesn't have to do at all with the change in the data. It has to do with changing the way you're presenting the data. So you want to make sure to pick minimum and maximums that kind of make sense, that aren't going to try to trick people. You could do the flip side. If you went to 45 for the maximum and let's say 30 for the minimum, now that looks like there's a humongous change. And that's actually maybe a little bit more realistic. I like to just always start with the minimum at 0, so you can get a sense of kind of where 0 pounds is at. That puts it into a little bit more perspective about what exactly has happened with our weight of the pumpkin. So the last thing I'm going to do here is we didn't add 6 cups. 5 cups was the maximum that we added, so there's no need to go all the way out to 6. So I'm going to click on this axis, and I'm going to make the maximum 5. Another thing you can do, you can sometimes change what the actual data labels are here on Excel. Let's see if you can do it here. It doesn't look like we can do it on Google Sheets. Google Sheets is not quite as good as Excel. I'd prefer to have it go 0, 1, 2, 3, 4, 5. At least right now I'm not positive if there's a way for me to do that. I'll let you know if I figure it out later. Usually I use Excel, and there is a really easy way to do that on Excel. So let's go ahead and change, kind of leave this the way it is, and that's just kind of a general thing to think about as you are making your data tables. Have a great day. Okay, one thing I'm actually injecting this into the clip because I forgot about it is how to add a trend line. I'm going to go ahead and move my axis labels back to kind of what the original numbers were at. Once again, it kind of differs in Google Sheets compared to Microsoft Excel. So if you've got Excel questions, feel free to ask me. But you can, if you click on the dots themselves, you'll have a little line that pops up, and you can click on linear, and you can see that line fits it pretty well. It's kind of like a line of best fit, which you will learn about in math. It's also possible to do things called polynomials. Those might be fits for data that's not just kind of a single trend, a single line like that. So it's something to think about.